Next we want to graph polar curves. Our first graph is r equals 3. So we have our polar axis here, and here we have 1, 2, 3, 4. Since there aren't any thetas in this problem, we know that r is 3 no matter what the theta is. So our curve is going to look like this, with radius 3 no matter what the theta is. That's it. Our next problem, we have to graph theta equals pi over 3. In this problem, there is no mention of r, so we need to keep the angle pi over 3, and r can be taken to be any value. So an angle of pi over 3 would be something like this. Notice that this extends down, if you're thinking about rectangular coordinates, into the third quadrant because the radius could be taken to be negative. So that's an angle of pi over 3 with a positive radius or with a negative radius, which flips it across. Next, we want to convert to rectangular coordinates and then sketch the graph. So here we have r equals 2 cosine theta. We know from up above that cosine, well, we know that x equals r cosine theta. So x divided by r equals cosine theta, because the cosine of theta is the adjacent over the hypotenuse, so that's just the same as what we know from trigonometry. So we make the substitution. Cosine theta is x divided by r. If we clear out the fractions, we have r squared is equal to 2x. Since we know that r squared equals x squared plus y squared, we can make that substitution. So then we have this. And it would be convenient to have all the x's together. And it would be nice if this were a perfect square, since this looks suspiciously familiar, like something we may have had to do in algebra before. This looks like it might be some kind of circle, and if we complete the square, we can see that it is in fact a circle. So the missing term here is half of -2, which is -1, squared. Since we just added a 1 to the left-hand side, we'll add a 1 to the right-hand side to balance that out. Now we have a perfect square, x minus 1 squared plus y squared equals 1. So this r equals 2 cosine theta is just a circle with radius 1 shifted to the right by 1. And there you have it. If you had changed this to cosine theta to sine theta, it would have instead been on the y-axis, a circle with radius 1. And if you modify the signs, you could flip it across the axis and have different circles there.